Hello and welcome to Math 20. This is Mickey and we're going to talk about proportions today. So for Math 20 this is section 5.3, but for everyone else this is just a talk about proportions. So proportions are one of my favorite topics, and this big fancy word proportion, all it means, proportion, just means two equivalent fractions. Okay. So if I say 1/2 is equal to 2 over 4, that right there is a proportion. That counts as a proportion. Those two fractions are equivalent. Okay, so writing that two fractions are equivalent means you have written a proportion. Done! Now, I want to show you some kind of magic thing about proportions which you might not have realized, okay, is that the cross products are equal. So this is the proportion rule. By cross products, the word product means multiply, and we're going across the equal sign. So 1 times 4 is equal to 2 times 2. And that's actually true. 1 times 4 is 4. 2 times 2 is also 4. So that's a really great thing to know about equivalent fractions, is that their cross products are always equal. And that actually helps us to set up proportions for solving, which we're going to do in a moment. But the first thing I'd like us to do is think about, if I wrote a proportion, how could I decide if I wrote that two fractions are equal, how could I decide if that's in fact true? So one question that we answer is to determine if the fractions are proportional. So if I say 5 over 6, is it equal to 10 over 12? Well, you might notice right away that yes, they are equal, because if I were to multiply by 2 over 2, which is the same thing as 1 whole, 5 times 2 is 10, 2 times 6 is 12. But then we could also use this idea of the cross products to check. 5 times 12, is it equal to 6 times 10? And yes, 60, 5 times 12 is 60, and 6 times 10 is 60. So yes, they are proportional, meaning they're just equal to each other. They're equivalent fractions. Okay, what about this one? Is 3 over 7 equal to 4 over 9? And we put a question mark here because we're not sure if they are equal. These ones were equal. So in order to determine if they're equivalent, we're going to use the cross products. So 3 times 9, is it equal to 7 times 4? 3 times 9 is 27. 7 times 4 is 28. They're not equal. So no, the fractions are not proportional. Okay? So, and this will actually come up, in terms of rates as well. We could use rates here within proportions. We can incorporate some units. So let's go back to the idea of the road trip for a minute. If Jan drove 200 miles in, what should we say, 4 hours, is that the same rate at which John drove? And he drove 500 miles, doesn't matter where to, right? In, let's say, 10 hours. So we could reduce each fraction to a unit rate, if we wanted to figure out if they're equivalent, or we could also cross multiply. So let's just use this new strategy. We were talking about unit rates before, and we would just divide, but let's do it both ways. I'm going to first do 4 times 500. 4 times 500. Is it equal to, oh yeah, we don't know if these are equal yet. Is it equal to 200 times 10? 200 times 10. 2000, 2000. Oh, spot on. And let's look at their unit rates. If I figure out the unit rate for Jan, I'm just going to go ahead and divide 200 by 4. And I see that Jan went 50 miles per hour. So this unit rate here for Jan, if I divide, is 50 miles per hour. Or pH, mph would be fine. And then John, you can see that those zeros slash 10 goes into 500 50 times. John also went 50 miles per hour. So those would be proportional because the cross products work and then also the reducing works. In the next video, we're going to talk about solving proportions and what we use proportions for. That video is just about setting them up and checking to see if they're equal.